Hello, Flames friends. It is your last week of math, so I just wanted to tell you that so you can know that you only have to do this 5 more times. You've got this. I'm so proud of you. Today we're doing lesson 32, session 4. It is finding the same perimeter with a different area. So perimeter is adding up all of the outsides, and then the area is when you multiply length times width. So perimeter is add. Or you can take this side and times it by 2, this side and times it by 2, and then add those together, and you'll also get the perimeter. So Kai drew the rectangle shown. What other rectangles have the same perimeter but different areas? So first, we need to find out what this one is because we need to know what the perimeter is and also what the area is. This rectangle is 4 by 2. So it is 4 and 2. So when you're trying to find the area of a shape like this, you would do the length times the width, and 2 times 4 is 8. So we know that 8 is the area. Now the perimeter is 2 plus 4 plus 2 plus 4. 2 plus 4 plus 2 plus 4. Or I can do 2 times 2 and 4 times 2 because I have 2 groups of 4. So 2 groups of 2, 2 groups of 4. 2 times 4 is 8. We just did that up there. 2 times 2 is 4. 4 plus 8 is 12. Let's do the same thing here. 2 plus 4 is 6. 2 plus 4 is 6. 6 plus 6 is 12. So I did it 2 different ways. So the perimeter, just put P for perimeter, is 12. When you are looking for the perimeter of a shape, you're going to need to know that you're adding up all 4 of those sides to get to 12. So in your mind, you need to think about, well, what are some options? What could I do? Something else to keep in mind, if you're looking for a shape with the same perimeter, it might be helpful to see if you can add up 4 plus 2 and see what you get. Well, if you add 4 plus 2, you get 6. So let's just try another shape that maybe follows that same pattern. So here it's a little bit, let's pretend it's 1 and 5. 1 and 5 equals 6, so it's 2 plus 4. So I'm going to do 5 times 1 would be the area. So it has a different area. The perimeter would be 5, I'll change that, 2 groups of 5, which is 10, and 2 groups of 1, which is 2. 10 plus 2 is 12. So that worked. That's a good way to find a perimeter that is the same, but a different area. So I definitely have a different area. So one of the options you could have done for this is 5 and 1. Another one that you could do would be, if you're looking for 2 numbers that add up to 6, you have 2 and 4, 1 and 5, and you also, the only number you're missing is 3. So 3 plus 3 equals 6. So we'll make this 3 and this is 3. 3 times 3 is 9, so I have a different area. Now I'm going to look for the perimeter. 2 times 3 is 6. 2 groups of 3, so I have this group and this group, is 6. 6 plus 6 is 12. So when you're looking for the same perimeter, you can have that little tip or trick, and that will help you. If you turn the page to 728, it explains in Picture It what we just did. So you can use drawings to help you find rectangles with the same perimeter in different areas. That's what works best for me, but you have to decide what works best for you. The perimeter of Kai's rectangle is 12 units. All of the rectangles below have a perimeter of 12 units. So here you have 5 times 1, and here you have 4 times 2. Here this was 2 times 4, so they just flipped it. Here's 3 by 3. You can't flip that. It's the same no matter how you turn it. And here's 1 times 5. Model it. You can use a table to help you find rectangles with the same perimeter and different areas. The table below shows the measurements of rectangles that have a perimeter of 12 units. The rectangle Kai drew is circled. So all of these have a perimeter of 12 units, but you can see the area, how it's different: 9, 8, 5, 3, 2, 1, 3, 4, 5. Number 1 on page 729 says, look at the table and model it. What do you notice about the sum of the length and width of each rectangle? Well, this was something that I had pointed out already, but the sum of the length and the width of each rectangle equals 6. So your answer for number 1 is going to be that the sum is always 6. And I will erase these. So hopefully you got those written down. So number 1, the sum means we're adding. The sum of the length and width is always 6. Number 2. Number 2 says, oh, excuse me, there's a part B of number 1. How does the sum of the length and width compare to the perimeter? Well, let's see, so then we're going to go over here. How does the sum of the length and width compare to the perimeter? Well, the sum of the length and the width is 6, and the perimeter is 12. So the sum of the length and the width is half. The sum is half, or to go back to our fractions, 1/2 the perimeter. So the perimeter was 12, and when you add the length plus the width, which is the sum, you got 6. 6 is half of 12. Number 3. Oh, now I'm back to number 2. Number 2. All of the rectangles have the same perimeter as Kai's rectangle. Explain why only one has the same area as Kai's rectangle. Well, the side lengths are the same, but the length and width are switched. So, let's see. All of the rectangles have the same perimeter as Kai's rectangle. Explain why only one has the same area. Oh, okay. So the reason why is because they're switched. So like she had first 2 times 4, they switched it and they did 4 times 2. So that's why only one has the same area as Kai's rectangle, because they're all different. So number 2. The side lengths are the same. The length and width are just switched. So hers was a 2x4, and then they switched it to a 4x2. So you're still going to get the same area. It's just different lengths and widths. It's like taking a rectangle that's like this and putting it on its top, or putting it on its top and putting it down on its side. Number 3, list the measurements of the rectangles that have the same perimeter but different areas than Kai's rectangles. So these are the ones that are right here on this page. So number 3 would be, you could have a rectangle that's length is 3 and its width is 3. I'll put that down. Another one that's different from Kai's is you could have a length of, I think I had 1, and a width of 5. You could also have a length of 5 and a width of 1. Number 4, how can 2 rectangles have the same perimeter but have different areas? Well, rectangles can have different side lengths that add up to the same perimeter, but they multiply to get a different number. So it's all about the operation that you're doing. So number 4, at rectangles. Can have different side lengths. All right, so I wrote, rectangles can have different side lengths that add up to a different number than when you multiply them. So you're adding all of the sides of the perimeter, but when you're doing the area, you're multiplying them. So you're going to have groups of, it's turning them into groups of when you multiply, but adding, it's different. Feel free to pause it if you need. Number 5 is asking about strategies, and it's saying, you know, which one is your favorite? Is it easier for you to use a model? Is it easier for you to use a table? So it's totally up to you what works better for you. Here you could put, let's see, this is model, or table, or draw it. So whichever one you like better. Like I said, for me, it's probably using a model, but to each their own. I'm going to go ahead and erase this. So now's the time in the video where you could pause me and write this down so you're following along. All right, I'm going to go ahead and erase now. We are on number 6, which I believe is on page 729. Okay. Number 6, look at the rectangle shown. Draw a rectangle that has the same perimeter but a different area. So same perimeter, different area. First thing you have to do is find the perimeter and the area of this rectangle. Number 6 has 3 going down and 5 going across. So it's a 3 by 5. All right, now what I'm going to do is I'm going to add up the sides and see if this works. 3 plus 5 is 8, and 8 times 2 is 16. Or I know that half of 16 divided by 2 is 8. So the perimeter, if I had to guess, is going to be 16. Now let's see if I'm right. 5 plus 5 is 10. 3 plus 3 is 6. 10 plus 6 is 16. Or I could do the other way, but this is a lot slower. 3 plus 5 is 8. 3 plus 5 is 8. 8 plus 8 is 16. So yes, this does in fact work. If you're looking for the perimeter, all you have to do is add up the length and the width, and that gives you half of the perimeter. Now, let's find the area, because I need to find a different area. So 3 times 5 is 15. That's my area. So now I know that my perimeter is 16, and I'm looking for other shapes that are 16. So I'm going to find other combinations that add up to 8. 3 plus 5 adds up to 8, but I also know that I can do 4 by 4. 4 by 4 is going to give me an area of 16. So my area is different. Check. Now let's see what my perimeter is. I can do 4 plus 4 plus 4 plus 4. Whew. 4 plus 4 is 8. 4 plus 4 is 8. 8 plus 8 is 16. I can do 2 groups of 4 equals 8. 2 groups of 4 equals 8. So that's this group, and this is this group. This is this group. 8 plus 8 is 16. So I did it with that rectangle. I can also do another one that would work. I could do, let's see, 5, 3, 4 plus 4. I could do 6 and 2. I could do 6 plus 2 is 8. I could also do 7 plus 1. So any of those will work. You cannot have 0 and 8 because then you wouldn't have a rectangle. You can't have a rectangle that has 0 sides or 0 inches, 0 cubes. It just can't work. So it has to be everything other than that. 7 and 1, 6 and 2, 4 and 4, 3 plus 3. I'm pretty sure those are the only combinations, but they give you a different one. So number 7, the area, oh, it says 7. Look at the rectangle you drew for problem 6. Is its area the same as, greater than, or less than the area of the original rectangle? So my area of 16 is greater than my area of 15. So I would say it's greater than. And it's because 16 is greater than 15. The alligator eats the biggest number. So for my example that I did, which is 4 by 4, it is definitely going to be 16 is greater than 15. Okay? So mine is bigger. Number 8, Mark is weaving a new rectangular rug that has the same perimeter and a different area of an old rug. The old rug is 9 feet long and 4 feet wide. If the new rug is 6 feet wide, how long is it? What is the area of the new rug? Show your work. So again, what I want to do is I want to see how big the area and the perimeter are of the rug that he's currently sewn or made. So this is problem number 8. And the old rug was 9 by 4. So number 8, I have 9 and 4. So first things first, I know the perimeter. Well, let's see. 9 by 4. Okay. So the old area of a rug is 9 times 4. 9 times 4 is 36. The perimeter of this rug is 2 times 9 plus 4. So 2 times 9 plus 4, I have 9 plus 4 is 13. 2 times 13 is 26. Let's just double check that. 2 groups of 9 equals 18. 2 groups of 4 is 8. 18 plus 8 is 26. So the perimeter that I'm looking at of his old rug, those are his diameters. Let's see. All right. Mark is weaving a new rectangular rug that has the same perimeter and a different area of an old rug. The old rug is 9 feet. The new rug is 6 feet wide. How long is it? So this one is a little bit tricky. So I don't know the perimeter. I don't know the area of this new rug. All I know is that one of the side lengths is 6. So I'm going to do the old school way of trying to find the perimeter. I know that it has to equal 26 because it says it's going to have the same perimeter. Okay, so I found the perimeter of the old rug because I know the new one's going to have the same perimeter. Oh, you know what I did? I drew too many 6s because it only has 4 sides. 1, 2, 3, 4 equals 26. So what I can solve is 6 plus 6. So I know that I can break this down into 6 plus 6. 6 plus 6 is 12, plus question mark equals 26. Now what I can do is I can take that 12 from the 26 to find out how much the 2 question marks are, those 2 unknown sides are when I put them together. So I'm going to do 26 minus 12. And I get 6 minus 2 is 4, 2 minus 1 is 1. Now I know that 14 equals question mark plus question mark. Most of you probably know, hopefully, I'll move over, that 14 is equal to 7 plus 7. So now I know 14 So you have one side that is 7 and the other side that's 6. Now let's try to see if this is right. 7 times 6 would give us the area of 42. So it would have a different area. This one is 36. The new one is 42. Now I can do 7 plus 7 plus 6 plus 6 to find the perimeter. 6 plus 6 is 12. 7 plus 7 is 14. 14 plus 12 is 26. So I know the length of the new rug is going to be 7 by 6. That's how long that new rug is going to be. All right, we are done with that, and we're moving on to the green, which is page 731. So problem number 1, if you need to erase or write down what I've written, go ahead and do so. Okay. All right, let's see. Let's see. So number 1 says both rectangular banners on the right have a perimeter of 14 feet. Write the area of each in the table. Landon, she's with Josiah. So you can call him and see when he's going to be back, but I'm recording. All right, both rectangular banners on the right have a perimeter of 14 feet. So write the area of each in the table. So we have some happy birthday banners that we, so if you notice in the first, if you take the length and the width, just in case you're still struggling with this, if you take the length and the width, they should equal half of the perimeter. So 6 plus 1 is 7, 5 plus 2 is 7, half of 14 is 7. So now all we're going to do is find the area of each one. So you take 6 times 1, and it's 6, 5 times 2, and it's 10. So it's funny how you can have the same parameter, but a much different area. So I'll write that down if you need to have it. So the first one is 6 times 1. The area is 6. And then the second one is 5 times 2, and it's 10, but they both have a perimeter of 14. Number 2. Draw a different rectangle that has a perimeter of 14 feet. Write the length, width, and area in the table. So we need a perimeter of 14 feet. So that means if we take the perimeter and we cut it in half, both of those sides need to add up to half of the perimeter. Well, the perimeter is 14, so half of 14 is going to be 7. So the perimeter is 14. These two sides need to equal 7. So I'm going to do 5 and 2. It should actually look more like this. Okay, but I'll do 5 and 2. And then it says write the length within in each table. So it would be 5 feet would be the length, 2 feet would be the width. The area is 10, perimeter 14. You could do anything. You could do 4 plus 3. You could do, let's see, so it adds up to 7. You could do 5 plus 2, 6 plus 1, 4 plus 3. Those are the 3 different options you could choose. Turning the page on to number 3. Number 3, use rectangles A, B, and C for problems 3 through 5. Show your work. All right. I'm going to draw these for you so we can use this as a model. The first one is 3 by 6. This is A, it's 3 by 6. B is 5 by 5. And C is 5 by 4. Okay, so it says which rectangle has the greatest area? So let's find the area of each one. Area is length times width. So 3 times 6, the area is 18. 5 times 5, the area is 25. 5 times 4, the area is 20. So your question number 3 says, which one has the greatest area? Well, it would be rectangle B. 25 is the largest of all of those. So the correct answer for that is letter B. Number 4, which rectangles have the same perimeter? Show your work. So we're going to find out what the perimeters are. An easy way to do that is to do 3 plus length plus width. Width plus length, 3 plus 6 is 9. 9 times 2 is 18. So let's see if that's right. 2 groups of 6 equals 12. 3, oops, I'll do 2 groups of 3 equals 6. 6 plus 12 is 18. So the perimeter here is 18. 5 plus 5 oops, is 10. 10 times 2 is 20. Or I could do 5 plus 5 plus 5 plus 5, and I still get 20. 5 plus 5 plus 5 plus 5. This is a shortcut. All right, I know that if I add those sides up and times them by 2, that will get me the perimeter, because the opposite is what I did earlier. I know the perimeter is 14. Well, half of 14 is 7. What 2 numbers add up to get 7? So it's all opposites. Multiplication and division are opposites. Addition and subtraction are opposites. You can use either one to help you find your answers and check your work. Same thing here. I'm going to do 5 plus 4 is 9. 9 times 2 is 18. Gosh, that seems familiar. Here it is. So now I can also do this another way of bringing this strategy in. It's 5 plus 5 times 4 plus 4 is 18. So the answer is A and C. Those are the 2 rectangles that have the same perimeter. They both have the perimeter of 18. Number 5, draw a rectangle that has the same perimeter as rectangle A and a different area than rectangles A, B, or C. Write the length, width, and area of your rectangle. Okay, this is fun. This is kind of like figuring out a puzzle. So rectangle A, it says it has the same perimeter as rectangle A, which is 18, and a different area than rectangles A, B, or C. So we have to find a different area. Okay, I'll keep A up, because I know the perimeter has to be 18. However, oh, I'm sorry. Yeah, the perimeter has to be 18, but it has to have a different area. So the perimeter of this rectangle A is 18. So it has to be the same. This is exactly what I was just talking about addition and subtraction and multiplication and division being opposites. If I need to find an object that has the same perimeter, I know that the perimeter, here's a trick of how I can find it. So the perimeter, 18 divided by 2 is 9. So I know that my sides have to equal 9. 3 plus 6 is 9. But I can't use 3 and 6 because then I will get the same area, which is 18. This new shape has to have a different area. So let's think of 2 numbers that I can add together that'll get me to 9. 7 and 2. So I'm going to say this side is 7 and this side is 2. 7 and 2. 7 plus 2 is 9. Good. So I could do 7 plus 2 plus 7 plus 2, or like I did before, 7 plus 7. I just put them in different orders. So the same numbers, just different orders. Here I'm going around 7 plus 2 plus 7 plus 2, and here I'm doing 7 plus 7 plus 2 plus 2. 7 plus 2 is 9. 7 plus 2 is 9. 9 plus 9 is 18. 7 plus 7 is 14. 2 plus 2 is 4. 14 plus 4 is 18. So I have the same perimeter. Now I need to find the area. I know the area is the length times the width. 7 times 2 is 14. My area here was 18. Do I have a shape that has a different area? Yes, I do. You could also have done any 2 other numbers that equal 9. So the example is 3 and 6, 7 and 2. You could have 5 and 4, because 5 times 4 would give you an area of 20. Let's see. I believe that's it. Oh, 8 and 1. So 8 times 1 is 8. We would have an area of just 8 on that example. Last problem, and then we're all done with this session. Woohoo, good job. Number 6, find the side lengths of 2 different rectangles that have a perimeter of 20. Then find and compare their areas. Oh my gosh, this is so fun. So you just get to play around with different shapes. All you know is that you have a perimeter of 20 units. They both have an area of 20. So I want you to start thinking of in your head, what is half of 20? Because that is how we're going to play around to find different shapes. Half of 20, hopefully you got, is 10. So the perimeter of both of these shapes is 20. In order to find shapes that both have a perimeter of 20, I need to know that 2 of my sides are going to equal half of 20. So first, I need to take 20 and divide it by 2, because that's finding half, and that's 10. So I can have one that is 1 by 9, and I can have one that is 3 by 7. So I'm going to do this, 1 and 9, and this one is 3 and 7. All right, so now I know I'm going to have the same perimeter because I used my cool strategy of making sure that both of these equal half of my perimeter. 9 plus 1 is 10, which is half of my perimeter. 7 plus 3 is 10, which is half of my perimeter of 20. Now I need to find the area because it says they have different areas. Find and compare their areas. So 1 times 9 is 9, that's that area. 3 times 7 is, oh my gosh, 21. So I'm going to compare these and I'm going to say 9 is less than 21. Or I could say 21 is greater than 9. Either one works. I'm comparing them. 1 is less than, 1 is greater than. They're not equal. Now, I'm going to just verify that I have the same perimeter of 20 on both of these. So I can do my strategy of 1 plus 9 plus 1 plus 9. And 9 plus 1 is 10. 1 plus 9 is 10. 10 plus 10 is 20. Or I could do 2 groups of 9 because I have 1 group, 2 groups, and that's 18. 1, 2, 2 groups of 1, and that's 2. 18 plus 2 is 20. So I found it 2 different ways. Over here, I'm going to do the 3 plus 3, 3 plus 3 equals 6, 7 plus 7 equals 14. 14 plus 6 is 20. Now I could also do the multiplication, which I like, or I could do 7 plus 3 is 10. 10 times 2 is 20. Because if you find this half, you know this other half is going to be automatically the same. So you could add up both of those sides and multiply them by 2. That's an even faster strategy for finding the perimeter when you know 2 of the sides. And it's a rectangle or a square. So I hope that makes sense to you. If not, please let me know. I'm here to answer any questions. Love you guys. Good job.